To understand a machine is to listen to its silence. The true rhythm of invention is not the clatter of gears or the hum of coils, but the geometry that binds motion to the invisible. Beneath every engine, every generator, lies a pattern older than industry itself, the pulse of magnetism, the reciprocity of field and form. The little motor on your desk, clear as glass and light as a breath, might appear a toy. Yet its turning shaft and glowing bulb carry the same principle that once moved the steamships of Watt and the dynamos of Faraday. Within that small frame, copper, iron, and magnet converse in the same timeless language, the geometry of induction. Electricity is not a thing, but an event, a transformation of pressure, a correspondence between the magnetic and the dielectric. To mistake it for motion of particles is to mistake the echo for the voice. When a conductor moves through a magnetic field, it is not cutting lines of flux, as the textbooks say. It is participating in the field's breathing. The generator is not a maker of current, it is a translator of equilibrium. The high-power compact motor and strong magnetic generator exists in this lineage, an educational tool that condenses centuries of thought into something a child can assemble. Transparent, precise, and tactile, it invites the learner into the same dialogue that once enthralled the great experimenters. Its form is modest, its heritage immense. Long before laboratories gleamed with instruments, power was something muscular and visible: wind, water, the heave of oxen. The dawn of the industrial age changed that understanding forever. The first steam engines taught humanity that heat could be disciplined into rotation. The first electrical machines revealed that rotation itself could summon light. In 1831, Michael Faraday turned a copper disc between the poles of a magnet and watched a needle tremble. That trembling was history's first glimpse of electromagnetic induction. From that moment, the world would never again see motion as mere mechanics. Every turn of the disc was a dialogue between the visible and the unseen. That humble disc, quiet and unadorned, is the ancestor of every modern motor, and of the small, transparent generator that hums on your table. The principle is the same: motion through a magnetic field produces potential. Not from fuel, not from effort, but from geometry. Nature answers proportion with flow. Faraday's discovery was not an invention but a recognition. The universe, he realized, is self-consistent. Every motion through the field creates a counter-motion, every tension finds resolution in equilibrium. The generator, then, is not a producer of energy but a witness to its continuity. Half a century later, Nikola Tesla and Mikhail Dobrovolsky took that insight and gave it form in the three-phase system. Three intertwined currents, offset by 120 degrees, created a rotating magnetic field, a living balance that could sustain motion without brushes or commutators. The field itself became the moving part. What began as Faraday's hand-turned disc became the humming heart of civilization. The same invisible rotation now fills our homes with light and warmth. And yet, even as our machines grew larger and more complex, the principle never changed: energy is not extracted, but revealed, when motion aligns with the field. This is what makes the compact educational generator so elegant. It returns to simplicity, to the experiment itself. Within its acrylic frame, a student can see what industrial progress has hidden: the very relationship between magnet, conductor, and motion. The invisible becomes visible once more. 100 years ago, classrooms across Europe kept small brass and copper dynamos for demonstration. A teacher would place a coil between two magnets, connect it to a galvanometer, and let the students watch the needle swing. The effect was magical. For the first time, the unseen order of the world had become tangible. The modern kit continues that lineage, but with precision unknown to the past. Clear housing replaces cast iron, neodymium magnets replace crude steel, and micro bearings make even the lightest touch significant. Yet the experience remains unchanged: the same wonder, the same whisper from the field. To understand energy through such an instrument is to return to the origins of science itself, to the moment when curiosity met geometry. The child turning the shaft today is retracing the motion of Faraday's hand, repeating Tesla's silent meditation on rotating fields. In the simple glow of a bulb, they are seeing the continuity of discovery. Energy, before it was a unit or a price, was a principle of life. The Greek word energia meant being at work. It was not something stored but something expressed, the activity of existence itself. In every coil of copper, that truth remains embodied. When the shaft turns, the field responds, not with force, but with proportion. A machine like this becomes a mnemonic of civilization's awakening. Its very motion remembers how humanity learned to converse with nature through geometry. Every bearing and axis tells the story of balance. Every spark of light echoes the first realization that magnetism and motion are two sides of one coin. The beauty of magnetic understanding lies in its symmetry. Before Faraday, magnetism was treated as occult attraction. After him, it became a living continuum. His insight, that motion through field gives birth to electricity, revealed that nature's laws are relational, not mechanical. Nothing is created, everything transforms. Tesla's later refinements, his rotating fields and polyphase systems, merely gave direction to what Faraday had seen. Together they uncovered a deeper order, one that would have been recognized by the ancient geometers, that power flows along lines of balance, not force. In this light, the little compact motor is not merely instructional. It is metaphysical. It reintroduces the idea that participation is understanding. To turn its shaft by hand is to witness the field's reply. The lamp that glows is the field's acknowledgement of your gesture. The most meaningful education begins not with information but with involvement. The child who spins a generator learns more than electromagnetism, they learn reciprocity. They see that energy is not extracted but exchanged, that every act of creation is a conversation with order. For teachers, such a tool is invaluable. It bridges theory and perception. Where textbooks offer abstraction, this device offers participation. The transparent geometry of its design transforms physics from memorization into meditation. The lesson is no longer about voltage and current, but about balance and transformation. In the old apprentice workshops of the 19th century, young engineers built scale models of engines and dynamos. These were not toys but instruments of comprehension. Each screw and bearing was a line of dialogue with natural law. The new generation inherits that same spirit, though their tools are smaller, their vision is the same. Industrial-grade construction ensures that this educational model is not ephemeral. The acrylic frame is clear yet resilient, the copper coils precisely wound, the magnets symmetrically aligned. It can be assembled, disassembled, and reassembled, a mechanical textbook written in the language of proportion. When the shaft begins to turn and the small light ignites, one sees more than demonstration. It is history reenacted. The Industrial Revolution reduced to its essence, made visible beneath the fingertips of a child. And yet, there is poetry in its simplicity. Each rotation of the rotor is an echo of the centuries-old struggle to understand motion itself. From Watt's pistons to Faraday's discs, from Tesla's rotating fields to the clear, humming classroom model, the same conversation continues. The great engines of the past sought to conquer nature. This small one seeks to commune with it. Its silence is its virtue. It wastes nothing, it hides nothing. It reveals, with humility, the same law that turns the planets and ignites the stars. Motion within the field begets energy. To an engineer, this is induction. To a philosopher, it is harmony. To a child, it is magic. The modern world too easily forgets that every revolution in thought began with the hand, with the act of turning, of feeling resistance, of sensing balance. The acrylic generator revives that forgotten intimacy. It restores the tactile link between human and field. In the hum of its coils is the same vibration that once filled Tesla's laboratory. In the glow of its lamp is the same revelation that first flickered in Faraday's mind. When a student watches that light awaken, they are not just learning, they are remembering. Such is the legacy of this instrument. It carries the entire heritage of industrial and electrical discovery distilled into a single gesture. It embodies the continuity between the colossal and the minute, between the generator that powers a city and the model that enlightens a child. Every part of it speaks a truth once common to all great experimenters, that the field is alive, and that motion within it is not exploitation but dialogue. The product's precision reflects its philosophy. Its strong magnetic generator and compact motor demonstrate both directions of conversion, mechanical into electrical, and electrical back into motion. The clear housing makes the invisible visible. It invites inquiry, patience, and respect for the subtle. It is not an app, not a simulation, but an embodiment. In an era ruled by screens and abstractions, it brings the hand and the eye back to their rightful place in learning. It reminds us that science, before it became digital, was physical, an art of participation. To hold such a device is to hold a fragment of the story of civilization. It connects the classroom to the laboratory to the workshop to the cosmos.
Every click of the bearing and shimmer of the coil whispers of an unbroken chain of discovery that stretches from the 19th century to now. Spin it, and you participate in that lineage. You are not merely observing energy, you are reenacting its geometry. The small engine on your table is the mirror of the great engines that built the modern world. But unlike them, it teaches rather than consumes. It invites reflection rather than conquest. It is the same principle made gentle, a reminder that the universe yields its power not to violence, but to alignment. The glow that follows is quiet proof that nature still responds to proportion. From the first hum of a coil to the soft light of a bulb, the compact motor and magnetic generator bridge 2 centuries of thought, from Faraday's disk to Tesla's field, from the industrial mill to the modern classroom. To watch it turn is to see the pulse of discovery itself. It is not merely a teaching aid or a product, it is an heirloom of human understanding, a continuation of the conversation between curiosity and the field. And so when you place your hand upon its wheel and give it motion, remember, you are touching the same mystery that has guided every scientist, philosopher, and engineer since the first magnet drew the first nail. The hum you hear is not mechanical. It is the sound of order awakening, the magnetic pulse of discovery, alive once more beneath your fingertips.